In Autodesk Inventor Professional, I can simulate simple kinematic motions, or I can go beyond the kinematic motions into dynamic simulation, where I can analyze gravity, forces, friction, put in all different kinds of timing, motion loads, so forth. So let's look at this in the assembly environment. So I'm going to put a transitional constraint between this face and this face, and let's go ahead and do the same thing between this face and this face, and between this face and this face. And actually on that one, let me do that one again. So I'll do transitional, and between this face and this face. And actually for some reason it doesn't want me to do that one. Let's just see if it gives me an error. So it gives me an error. So I have something that I need to fix in here somewhere, and I forget where it was. Actually, I've got one here, got one there. I've got that one twice. So let me delete this one, and so I've got this one, got that one. Let's see if I can put that in again. Now I had some trouble with this when I did a trial run, so let's see if okay, there we go. Alright, so now if I move this, the followers move as I would expect them to, as long as I don't go too fast, faster than the mouse can, or than the calculations can keep up with it. So this one is just a cylinder. Alright, so that's the kinematic motion. But let's look at the dynamic simulation of this. I'm going to suppress these three constraints, or these three. So let's suppress those, and I'm going to go to Environments, Dynamic Simulation. And so in dynamic simulation, I have a whole library of different types of joints. If I click on the joint and I go to the joints table, and so I have a whole bunch of standard joints for revolution joints, prismatic, cylindrical, point line, spatial, or just 6 degrees of freedom. So a whole bunch of different types of standard joints, and then I have some rolling joints. Now, for example, on this rolling joint, and it'll show me a preview here, it shows a rack and pinion. But think of that as, say, if you have a tire going down the road, a cylinder. The tire is a cylinder on a car, on an automobile. As long as it isn't slipping, you haven't stepped on the accelerator too hard or the brake too hard, then it is acting as a rolling cylinder on plane. And so have all of these different types of joints in this category. And then I have some sliding different types of sliding joints, if I want to follow a cam path or whatever, and 2D contact. So why it's if it doesn't move out of plane, so this part doesn't move out of plane, this part doesn't move out of plane, so I can define a 2D contacts between those. If it does move out of plane, I can do the 3D contact. And again, this is just an example image. It could be any mechanism that has a 3D contact, or any mechanism that has a 2D contact, or put various springs in there. So let's look at how all of this works. So I have a prismatic joint. So prismatic is straight line. It only moves along one axis. And in this case, the triple arrowhead is a Z. So this pin can move along the Z-axis. Same way for this one back here. It can move along the Z. This can revolve, and this one can translate. On the revolve, if I go to the properties of that, I can do things like put torques, friction, so forth on here, but I've enabled an opposed motion. Now I could graph the motion, maybe speeding up and slowing down, various motion laws. You know, I got a lot of different ways that I can describe the motion of this shaft, and but I'm just going to do it as a constant velocity. And so I'll tell constant velocity 360 degrees. I could also define by position or acceleration. For the shaft, it makes sense for degrees per second. And so I've put in that, you know, I've defined gravity here. And so I have gravity going down in this direction. And I'll go ahead and put this into motion. And so here we see it playing. If I want to reverse the direction, that's no big deal. But I'm doing a lot more than motion. If I come up here to the output grapher, and I say that I want to know the acceleration of one of these joints. Let's stop this for a minute. And I'm going to go to the this first prismatic joint. And so there's a whole bunch of information that I can graph. Position, velocities, acceleration, forces, so forth. So maybe I want to know the acceleration curve as that for this one, or for this one back here. So let me play that again. And so I'll play that. And so it's graphing out the acceleration curve for this cam. If I want the position, now the acceleration is overwhelming the position. So here's the change in position of the pin. And so a ton of different bits of information that you can graph, and it's only scratching the surface of dynamic simulation in Autodesk Inventor Professional. I almost forgot an important little bit that I wanted to demonstrate. So right now I have gravity holding these pins against the cams, but if this starts spinning really fast, then gravity may no longer be able to hold these pins against the follower, against the camshaft. And so if I put a spring force in here, and so let's do a spring force. I'm going to put a spring force. Normally you'd have some kind of geometry to hold the spring, but I'm going to put a spring force in between here and here, and then I need to edit that spring force. And so let's go to the properties of that spring force, and I'm going to make the this is just for visual effects, but I'm going to make the diameter a little bit bigger. Let's say the radius or 2, make it look smoother, number of facets 10, so forth. I could change the color if I want to change the color to, you know, whatever color I want. Anyways, let's put in the force. And I measured, I think it was like the minimum or the maximum distance was something like 12.5 millimeters. I forget what it was. But let's say that I put in the free length. So when I take this spring out of there, it expands. Let's say the free length is 15 millimeters. Okay. And let's say that I put 10 newtons per millimeter. So for each millimeter that this compresses, it puts 10 millimeters of force. So I've already put a preload on here because I've already compressed it to put it into this mechanism. So about a 3 millimeter compression, so about 30 newtons of force preload on that spring. I'll put in some dampening value here so it doesn't bounce around a lot, and we'll say okay to that. And so now that spring, we're not relying just on gravity. We have that spring holding the follower against the cam. So again, that's Autodesk Inventor Professional. Students, schools, faculty can download Autodesk Inventor Professional for free from the Autodesk Education Community website.